All right, this is chapter 6. We're going to talk some about some of the hardware. The difference between 6th edition and 7th edition, or 5th edition. 5th edition just said network hardware. Now they added a little bit more to this chapter, so it's okay. It won't be under test, so it's good. All right, network interface cards. That's how we connect to the internet. Nowadays, they're pretty much all integrated. Do y'all have a clue what I'm talking about? In other words, it's the thing you plug this cable into on the back of your computer. Well, they're mainly integrated. We'll see some pictures, and I brought a couple we can look at. Okay, they enable us to talk on the network. Okay, easy stuff there. It's a transceiver, transmitter, and receiver, all built into one. Okay, transmits and receives. Works at the data link layer and the physical layer, pretty much. The lower levels of the OSI model. Okay, handles the signal, converts it to electronics or light if you got a fiber optic. Okay, handles the addressing. The network card is the thing that when a signal's cruising across the wire, it listens to all the traffic and then only accepts traffic that belongs to you, that kind of stuff. All that's done by the network card. Okay? Okay? It has smart hardware, handles management, buffering. There's network cards. You can buy a network card like this one here, maybe about $30. You can also spend hundreds and hundreds, even thousands of dollars on these, depending on what you want it to do. So they can get very, very, very expensive. They could have management capabilities. They could have buffering. They could have different speed. They could have some with processors built into them. There's all kinds of different stuff. Traffic filtering. So they're pretty awesome. Okay. They don't really analyze it. That's really handled farther up. They do handle the addressing of it. Okay. Everybody has them. I was looking today. Let's see if I can find it real quick. It's kind of interesting. Let me see if I can find I might go buy this weekend. This is a Wi-Fi enabled light bulb. Okay. I mean, it changes color. You can turn it on and off with your phone. You can make it change. I was going to, but they have them at the Apple Store. I can go pick them up. I don't know why they're at the Apple Store. They work with anything, but they're pretty awesome. I was looking at, there's a bunch of different ones out there. I don't know if they got a video. But there's a couple different videos. But you can have it where the light will blink when you get a text message. You can have it automatically dim down at night for your kids. You can have it come on in the morning to wake you up slowly. They're just
LED lights?
LED, yeah. They're all LED.
Probably use those for hearing impaired people when the door knocks and some sound goes off.
$30 a light bulb.
Actually,
$400 for like 4.
You need to get basically the control box initially. It's like 3 bulbs and the controller for $200. Then it's like $50 a bulb or $40 a bulb, maybe less. I couldn't remember exactly what it was. I think there's a bunch of different ones.
What's the reliability of the light bulb?
25 years. 25 years, and you know it's. But it's just amazing. It's all done through Wi-Fi. It's like, what the heck? So pretty much everything's going to be Wi-Fi sooner or later.
So if we hack your network, we would screw with your light bulb.
Exactly. You know, I was in California. I was, opening my garage. My garage doors have internet on them now. So we're get to the point where anything can be done nowadays. But I saw common in every device. Yeah, they're going to be common in everything. It's just, I don't know. It's pretty awesome. Okay. Before you're ordering and installing, you need to know which type of interface you need. How is it going to plug in? Okay. A lot of times, I had a Dell server for one of my clients that about midnight every night, the backups would fail. And we couldn't figure out what the heck was going on. And I ended up putting a machine out there running Wireshark, capturing the network traffic at midnight. Sure enough, at midnight, I would lose connectivity to the network. And we still couldn't figure out what the heck it was, but it was an integrated network card on a server. So Dell, replaced the entire motherboard or send me a real nice high dollar add-on card, kind of like this, which they did, and solved all my issues. But really, how it plugs in is a big issue. We're going to look at that. Okay? The access method, the speeds, the connectors, the compatibility, all that stuff you need to think about. How about manufacturers? Could that be an issue? A lot of times, different manufacturers work better together. We ordered some computers, so it's been years ago now. There was like 203 202, 206 for a bunch of different classrooms. They all came in on one order. They came in with two different network cards. Half with Broadcom, half with Intel. It's like, how can you make one order to Dell and you get two different network cards? But they did. It was kind of weird. Okay? And enhanced features, all kinds of different things. Okay, the bus. The circuitry, the pathways. That's the stuff on here, which we'll see in a picture of in a second. The motherboard transmits to it. It handles the data back and forth between it. They differ on capacity, the path size, and we're going to see. In a minute, we're going to see a picture of it. There's also different expansion slots. I mean, anyone ever look at the inside of the computer? Hopefully, we all have at one point. We take in micro hardware, hopefully, most of us. If not, you probably will at one point or another. Or you've got your A+ or something, or whatever. But different expansion slots allow you to expand your computer and add stuff. Okay. Let's see, circuit boards. Just all kinds of different stuff can be added. And we're good at there. Okay, we're getting close to seeing it. We've got PCIe, which is PCI Enhanced or Express. I'm sorry, Express. And what gets me, anyone know what kind of bus this is on this card?
PCI.
Yeah, this is PCI. What's the other kind?
PCI Express.
No,
CIT?
ISA. Remember ISA? Remember that? Remember how ISA was bigger? Okay.
32
Sounds familiar.
And then PCI was smaller and it's quicker. But then look at PCI Express. I mean, think how small that is compared to this. It's faster, but now instead of all these, now we just have a couple. So I think it's just amazing how the actual interface changes. Okay. Anyone ever tried to put the wrong size card in the wrong slot? Somebody, who was it? That was one of our students. Tried to put the memory in backwards. No, it was my son. That's what it was. My son in Arizona. I'm like, Micah, did you put the memory in right? Because it wasn't working. He goes, Dad, it fits in both ways. I'm like, no, memory only fits in one way. No, it fits in both ways. No, it doesn't. It only fits in one way. If it fits in both ways, you screwed something up. And sure enough, you kind of screwed something up. Okay. The PCI is 32-bit, a gigabit per second, 2004, so it's kind of new. Okay. When looking at it, you got to read your documentation, see what you have. Just ask, I usually buy Dell because I like it because you can go on support.dell.com, look up and see what you have. It's easy enough just to see what's in it, all the different components about it. Okay. If you have more than one slot, look at your motherboard basically or documentation. Okay. Okay. You can add on other network cards. Like I have one here. USB. It's actually not a network card. It's actually Bluetooth. But we have some around here that are network cards. This stuff, looks just like a flash drive. So people don't even realize this could actually be a network card plugged in your machine rather than a flash drive. So they're really small. Okay. There's PCMCA, which I didn't have one to bring up to you, but that's the kind of like fits in the older laptops. I think there's a picture coming up. We have USB, we have compact flash, FireWire. You might have to configure them. There's an external USB one. Okay. Pretty easy to do. And nowadays they're pretty much plug and play. That means you plug them in and they work. For the most part. Okay. Onboard network cards that connect directly to the motherboard. And I don't have a machine here to show you, but they're built right in. You just plug them in, we'll see a picture of one. Okay. Just like the mouse and keyboard ports. I've noticed that remember how we used to have the PCI ports for the PCMCA? Not PCI. The mouse and the keyboard. They were the round connector. PS2 connector. I can't remember these names there. We had the PS2 connectors. Then they went away and we got all USB. The new ones we got from Dell now have PS2 slots again. Anyone know why? What's up with that? Are they going to start reselling PS2 mice or something? Well, all of a sudden they're back on the computers we're ordering. It's like, why do we have PS2 ports again?
Well, the computers we order out the base are the same.
Yeah.
My motherboard is an ASRock. It didn't even come with a PS2.
Yeah, it's like, why do you need them anymore? But then all of a sudden we got them back again. So I don't know. It's weird. Okay.
A lot of devices.
But now pretty much everything has a network card integrated into it. You might as well. It's fairly fast. Saves space, frees expansion slots. So kind of nice. Okay, here's our motherboard. We have our slots right here at the bottom. We have the USB. We have our network cards. Probably FireWire or something. It's hard to tell. More USB. There's our PS2 for our mouse and our keyboard. We have our other expansion slots here. Okay, we have some here.
Those are the memory ones up there.
Yeah, the memory's
Upper
up
left.
top.
Well, there's the memory. Yeah, there's the memory. That's hard to see. There's the memory, and there's our expansion slots. There's no PCI Express. Is that PCI Express?
No, it's a little riddle.
There's two PCI Express.
There it is, that one.
Yeah.
That one right there. Okay, it's hard to see. But so you can very easily upgrade your stuff. One thing I'm thinking about getting is a new video card, because now with all the video compression stuff I do, it takes forever. It's like, what the heck? So. All right, installing them. Read the documentation. How many people actually read documentation? Daniel's the only one. I very seldom ever read that stuff. Once in a blue moon. But I think one of the main reasons I stopped reading it, and whenever you get a Linksys router, you know, they get it taped over the ports and says, whatever you do, insert CD first. Does anyone actually do that?
No.
Well, Jeff Caldwell, the guy who works next door over in academic, used to be our associate dean here. He was buying a new one. He said, Jeff, don't plug in that CD. You're going to have issues because they ask questions that if you have no clue, you kind of could screw it up. Well, he went home, plugged the darn CD in, screwed it up to the point where he couldn't use it anymore. I had to bring it back, so I had to reset it all on him. But, you know, I just barely don't ever read the documentation anymore. Okay. Gather your tools. Ooh, that's probably a screwdriver. Unplug it. Plug it in. You know, ground yourself, plug it in. Place your cover, turn it on. That's pretty tough. Okay. Here's a 3-com, very popular. Actually, they were popular. They're not as popular anymore. Okay. But this is just a regular 3-com network card. Regular RJ45. This one's 10 or 100. Okay. So it's nothing special. This one actually has link lights on it. Some do, not all. Okay. We also have. Okay, what's this? Anyone know what this is? 2 ports on it. It's a 56K modem. See, some of you have never seen one of these. Pretty awesome stuff, huh? We have modems. How about these? Wireless cards. Okay, these are getting very popular now. A lot of people have wireless now. So, you know, there's just a ton of different kinds of cards out there. So, all right. That's a properly inserted expansion card. Yay. Okay. Install your driver. A lot of times the driver will install automatically. If not, you just slap the CD in at that point. Why aren't the drivers always included with Windows? Anyone know? Because they're always updating the darn things. And they're always making new hardware. And so that's why. Okay? All right. If you buy it with it, a lot of times the driver's already installed. If you buy it afterwards, you have to install the drivers. Depending. You don't always need to. It's like what gets me is you buy a monitor. You ever notice monitors always come with CDs? Whoever installs the monitor software. I think I did one time because that was the only way I could get a certain resolution. But you very seldom ever need to install the monitor drivers. Okay? A lot of times there's built-in drivers in our operating system, what I mentioned. Okay? If they're not available, you download them from the manufacturer. But that's one issue. Sometimes if you don't have a network, it's kind of hard to download them. So I always make it a habit to download that stuff first. Makes it easier. Or the wrong one, that could really screw up your machine. Yeah, I've had that happen before. Okay. Verify that it works. Make sure it can function with the network. There's always diagnostic tools. There's lights depending on which kind of card you have. Read your documentation. Yay. You can ping and stuff like that to make sure they're working. Okay. There's some that can be done without, like these here, the USB ones, you can actually swap them out without even powering off your machine. Not everything can be done that way. Okay. There's also converters from RJ45 to gigabit. And the fiber optics, I mean, there's all kinds of different ones out there. Okay? And they're teeny tiny now. Okay, I think they have a picture one. There we go. Here's the gigabit. It's RJ45 to, there, that's, wait, what? Is this the one that does fiber?
One on the right is fiber.
Okay, one on the fiber is, okay. So you can convert fiber. There's just all kinds of them. All right, repeaters. Those are just like an extension cord. They just repeat the signal. Okay. It really doesn't interpret it, doesn't route it, doesn't do anything, just expands it and sends it back out, regenerates it. A hub is very similar to a repeater. It basically is a repeater. Okay? One input port, multiple output ports. Okay? Not seen much anymore. Okay? Then we have our pass cables that connect to them. Okay? All right. Then we have bridges. What's a bridge do in real life? What does a bridge do?
Connects two light masses.
Okay, but normally they're like two different cities or something. It basically creates one area. And it bridges the network. It actually creates two networks together. Multiple segments of the same network. See, routers connect different networks. Bridges connect the same network. But really, bridges and switches are all the same now. I gotta sneeze. Okay. They analyze and make decisions on where to direct them. They work at the data link layer. Normally have one input and one output port. They really don't care on the protocol. They just forward it on. There's a bridge. Yay. Just connects the two hubs together. That's all it is. Allows you to connect two different network segments together. Not seen much anymore. Now we use switches and routers for all of that.
They use Wi-Fi bridges.
Yeah, that's true. Wi-Fi expanders as well. I've seen those. You can actually get one wireless access point connected to another. Is what you're talking about.
Like when you have like a 5 gigahertz trying to connect to 2.4.
Ah,
And
okay.
I got a bridge to make it work.
Oh, that's cool. But I use one for expansion to make it work farther. Basically, a friend of mine had one in his house, and he wanted to make it work outside, so we just put basically a repeater kind of thing. Well, that's cool. All right, switches. We've talked about these in multiple chapters already. Okay. They subdivide your network. And they work at the OSI layer, the data link layer. I'm sorry. Okay. Work at layer 3 or 4. They can interpret the data now and only forward on to the correct ports. They have a processor. They could have memory and operating system. Really depends on the one. If you buy the cheap ones like these, there's not much management involved in them. Okay. How to install them? Just plug them in. That's pretty much it. Now, if you got the more expensive ones, then you're going to have to go in and possibly use the software. Like these don't even have a port. Like the ones we have down the hall, you actually connect via serial cable. You log in with Telnet or whatever, and then you can configure them that way. Okay? Normally the lights tells if it's working. You can configure it if needed. They're not that hard to do. Okay? Normally on switches like this, it really doesn't matter which one goes to the internet. Pretty much, I usually try to pick port 1 or port 24 or something, so you know, but it really doesn't matter all that much. You made it. We've been waiting on you. I've been sitting here for 20 minutes. All right. Oh, while I got you, chapter 5, 6, and 7, I put some homework in the quiz area. It's just the end of chapter questions. So just do those. The one due each Sunday. Okay. Difference in switching, they can't interpret the frames. Okay. And they can forward based on that. Like this switch here can determine which port it came in at and which port it needs to go to. So rather than sending it to everybody, it just sends it out to the one port that needs it. Okay. All right. There's all kinds of different ones. There's cut through. Store and forward's probably one of the most. It's not supported on these, but what store and forward does is it'll actually store the packets until it receives an entire thing. Like say we have a big transmission that's broken up into packets, it can store it, put it all together, and then forward it on. That way, because one way viruses not get through is they break it up into pieces. And you can't tell what it is because they're broken into pieces. These switches can all put them back together. Okay. All right. Okay, the cut through reads the headers. Forward is based on the entire packet. Cannot determine the integrity, though. Okay. And where's the other one? Oh, okay, get there. Yeah, can't determine corrupt. We talked about that. It's very fast. It really doesn't do much to it. It just sends it on. Your store and forward areas. Reads the entire data frame into memory, checks for accuracy, and determines what to do. It's slower because it has to retrieve the entire thing, okay? But then forwards it on from that point. Okay? It's not critical, this stuff. It's not all that. I mean, I don't know. It's just, you don't have to do much with it. Okay. VLANs, virtual LANs. It's kind of like a VPN if you want to think about it. With VLANs, you can actually say, certain switches like our phones, they function on a VLAN. Our phones here, yeah, they're all on a separate VLAN, so they can actually manage all of them remotely. It logically separates the phones from the other network. When I worked at the Cox Convention Center, when Ticketmaster came in, we had to create a separate VLAN. So all the Ticketmaster stuff was on a separate network from the Cox Convention Center and now the Chesapeake Arena stuff. So you can actually use a switch and say, this port is one thing and another port's a different thing. Down at the end of the hall here, room 201, that's on the same switch as the other row state stuff, but one specific port is set up with a VLAN to keep us separate. Okay? Just allows us to be separated off, basically. Okay? We already talked about broadcast domain in the last chapter, but it's all the ports that receive broadcast traffic. Collision, it says ports in the same broadcast domain. We already kind of talked about that last time, too. I seem to be repeating a lot of stuff here. Okay. Here's a VLAN. So we have certain machines all on one VLAN, certain machines on another VLAN. Then we have machines that aren't on any of the VLANs. So it's a virtual network or a virtual LAN. So these 1, 2, 3, 4, 5, 6 machines, even though they're on 2 different switches, all function as the same network now. Kind of a cool setup. Okay? Advantage of it's flexible. Can you imagine if on this picture here we actually had to have those separate, like totally separate switches? These could be in a different state or a different part of the building even. So we'd have to have separate switches and everything. Now you can do it all on the same. Okay? So very flexible. Use any node. Okay? But again, you have to have a switch that supports it. These switches here don't support it. Reasons for it: separating them out, isolate connections, identify priority, legacy type stuff, separate large networks into smaller subnets. Terry Byers used to take care of a company doing a lot of AutoCAD type stuff. It worked with files that were gigabytes in size. So you could put the engineers on their own separate VLAN so their traffic didn't interfere with the rest of the network. So you just broke it apart. That's all it did. Okay? Alright, they're normally configured with one VLAN. Everything works as one. But you can create separate. You can create additional ones. You can actually create quite a few. Ours down the hall, I don't know if there's a limit. I think it's like 16 or something. You have a whole bunch of separate VLANs. And you can have specific ports that are on there. Okay? There's all kinds of different parameters and filtering and stuff you can set up with those. We're not going to set those up in here, but you can. Okay? Normally it's all done through the switch. Ours down there, you just log in. If I knew the IP, we could do it from here, but I don't know what the IP is. Okay. Potential problems: cutting off groups from the rest of the network. If you configure them wrong, maybe you people on your VLAN can only see each other, can't see the rest of the world. That would kind of suck. That was the issue I had when I originally started to help set them up at the Cox Center. Ticketmaster was on their own separate network, but that's all they could see is their own network. That was right about the time I was leaving. I basically said, they paid me $500 a month to take care of their computers, and they went from maybe 10 computers to about 30 computers, and to about 50 computers. Then all of a sudden Ticketmaster came in, they went to 100 and something computers. I'm like, no, we're done. So they hired someone to take care of it. And he actually came over right when we were doing this. So it's a lot of work, not for a part-time person. So, okay. But there can be issues with it. Okay. And the trunk is talking about switches interface carries traffic for multiple VLANs. So you can actually have certain areas that go over both. Our road state network has our video VLAN, has the wireless VLAN, our cybersecurity VLAN, all on the same cable. That's what trunking is called. Okay? All right? And we can't separate data. And what ends up happening is that any of the traffic that comes from room 201 is flagged as being from that specific port. So when it gets to other parts of the campus, we know where it's coming from, and it's kept separate from everything else. Okay. All right, and we can have one VLAN, another VLAN. They can connect back and forth. So those trunk ports could actually have multiple data from all the VLANs on it. Think of a trunk just like you see for the phone company, just a big old line that has a whole bunch of cables in it. The trunking on here is just one that has a whole bunch of different VLAN traffic. That's all it is. All right. Spanning tree. How many people, you guys haven't taken the routing class yet, have you? No? Well, you will be. He goes over this in like 10 times more depth than I ever will. He does the entire first half of the class just over these protocols. It's been too long. I haven't played with him much. But a lot of different protocols. And if these are on your exam, I will remove them. Okay? Because I don't know enough about them. But there's a bunch of different ones. I haven't messed with them yet. There's spanning tree. I know a couple of them I can talk about. Let's see. Go on to another one I can talk about. Different switches where they route at. So I'm just not up to date on all this stuff as much because that's why the routing class covers it. There we go, routers. That's what we're going to talk about the other ones. Okay. Now, we all have a router in our house. We all know that. We have routers down the hall. But even if you have a Linksys router, you don't even really think it's a router, but it is. Okay. It connects 2 different networks. Normally connects your lanes to your WANs. In other words, your internal to your external network. They can be different speeds. They don't have to be. They can be, but like at your house. I have gigabit internal, and I think I have 100 megabit external. Okay. Operates at layer 3, so it separates it out. It handles addressing, They are protocol dependent. My router at home only works with TCP/IP. They have some that can handle multiple protocols, but those aren't really. Everyone's on TCP/IP now, so it really doesn't matter anymore. Okay. Slower than switches in the bridge. So why do you think they're slower? Because they actually have to look at all the traffic. Rather than just forward on, they actually have to make the decision of what the traffic is, where it's going, so that's why they're slow. Okay. They have to interpret it. Okay. So traditional standalone routers didn't do a lot, but now they're still there, but now they're all specialized. Okay. They can do all kinds of stuff. They can, phone calls, they can just do all kinds of stuff. Okay. All right. Intelligence. This tracks node locations. They know where they're at. They use different ways to get there. There's one called OSPF, which I think we'll get there in a second, and RIP, which we're going to talk about. So there's different ways we can use to determine which way to go. Okay. They handle dissimilar networks, so you can have a bus connected to a star, or different internal networks connected together. Okay. There's obviously with large networks, you need lots of them. Every network needs one. Okay. We have a processor, an operating system, memory. Memory is kind of important in the process. When I ran my ISP at home, I had a Cisco 2500 router. Somebody might know what 2500 is. One of the low-end routers. Worked great. And I added my second T1 with the same router. It was starting to peak out my processor. When I added my third T1, I had to get a new router because it couldn't handle it. Because it takes a lot of traffic. And I found that when you're configuring the router, you do something called an ACL. Anyone ever heard of an ACL? Access Control List. It's like the rule set. It's the set of rules to process it. Without my ACL running, my router was super fast. Once I started adding my ACL or my firewall rules to it, it got very slow and it was about killing it. So depending on how you configure them, you might need more memory, faster processor, all that stuff. Okay. All right. They can't have multiple slots. Mine actually had 4 slots. Normally they're just 2. You can have more though. There's inexpensive home ones, which a lot of us have. There's thousands of dollars. Normally, a Cisco router is actually very cheap. You can get the routers for nearly nothing. But the interface cards that go in them, like the T1 interface cards, the CSU, DSUs, all those cost money. Okay. There you go. Here's some big routers. They actually have one similar to that down the hall. There's a home router. All kinds of different ones. All right. Router capabilities connect dissimilar networks. That's what they connect 2 totally different networks together. They reroute traffic or route traffic. All right, some other functions. They can filter broadcast. Broadcast cannot go across your router. Broadcast stay internal to your network. That's why when I told y'all to go home with your cable modem and plug your laptop outside your router, you will see all the traffic because the router is actually blocking. It blocks all the broadcast transmissions. Okay. Handles segregation. It does security. Supports all kinds of connectivity, just depending on what you have. Could be fault tolerance. It really depends on the type of router you have. Some do monitoring. Ours down the hall actually can monitor the amount of traffic that we're doing. Can handle for diagnostics. They can send alarms. There's just all kinds of stuff they can do. They can send results to a logging server. The router can do pretty much anything. I mean, even your home router, it can detect an IP address change externally and update a dynamic DNS. They can do all kinds of stuff. All right, interior routers is directs data between nodes on the LAN. So at your house, you probably have some ports on your router, so it routes traffic between those. Exterior, it connects your internal LAN to the outside portion. Okay. Border routers is where it's connecting the LAN to the WAN. Okay. And a routing table, I think we looked at routing tables in here before. It tells it where to route. And we're actually going to see some ways of doing that. Static routing, it says routers configured to use a specific path. Not used that much anymore. With static routing, you say, to get to Dallas, take I-35 south. Well, that's fine. What happens if there's traffic? Well, you don't have any choice. You have to take 35 south. Okay. Dynamic routing can automatically update based on the routing protocols and based on all kinds of different stuff. Okay. Installation is very simple. You normally configure them via the web. Right. Here we go. We have our different routers. They all can connect to the internet. You can get routers that have more than 2 interfaces, so you could have all those actually on with one router, but it's just a picture. When you take the routing class, you'll configure multiple of these. We didn't have a router simulator you can play with. Okay. Different protocols. Okay, there's best paths, the most efficient route from one node to another. Is there anyone out here that's like me, always trying to figure out a shorter way to get somewhere, a little bit better way to get there, a faster way to get there? A friend of mine, used to always drive from Choctaw to Memphis City and always took back roads. Never go on the highway. Is anyone that does that? Is anyone going to admit it? That always drove me crazy. Like, nope, don't like the highway. Like, how can you possibly drive without hitting the highway? But I'm always one of those. I'm always trying to find a little bit better way to get somewhere. So I'm always trying to figure. That's what routers do. They dynamically can figure out the best way to get there. They can go between hops. Hops is how many routers it has to go through. So which one has the less hops? Y'all heard about FedEx and UPS, how they're saving millions of dollars? It actually came out a couple years ago, but they redid their routing software to make them take right turns. We don't think about a right turn, but remember right on red, the whole right on red? They redid it so their routes now take as many right-hand turns as possible. So some of these stoplights, you might stay there, like the stoplight at I-40 and Sooner Road, what's that, a 2 or 3 minute stoplight? If we could do a right on red there, we could be saving a lot of time. So just by changing the route, saving tons of money. Okay?
It's actually safer too.
Oh, very safe, yes. Very good. And they're safe. It's just amazing. You know what gets me? They have the ability now to tell you where your package is any second. But they won't give that to us. I was like, why won't you? Then if you think about it, though, would you really want someone to know that? Because I could sit there and track Jason's package. It just got delivered to his house. Jason's at work. I could go pick that baby up and have me a new whatever. So I can see why they don't want to do that. But, I don't know. It's kind of cool. So, all right. You could also go with network activity. How much traffic's on that node? It can go on a different node. If there's a link unavailable. So all this stuff can be used to determine how to go. Okay. You can also go by protocol. Okay. Then we talked about number of hops, load, the cost. Now, are we talking dollars when we're talking cost? No, we're talking in time. Okay, that kind of stuff. Okay. We're going to get to the protocols here in a second. Time routers take to recognize the best path. Takes up time. Okay. So in other words, how long does it take to figure out where to go? It's like your GPS. How long does it take to calculate where it's going? Okay. There is overhead to manage all these protocols, and in a minute here we're going to talk about them. There's distance vectors that's determined best based on distance to destination. On internet, would that always be good, you think? Calculate the distance to get there, is that always good for the internet? I don't know, because I know sometimes going from here to my house goes through Dallas. Is that an efficient way to get to my house? No. But it might be the quickest, because that could be where the high-speed link is. Okay? It could be hops, latency, network condition. There's routing information protocol. There's RIP and RIP2. RIP2 is used now. It says only factors in number of hops. In other words, how many routes between here and there. Okay. There's also IGRPs, a part of it, the gateway protocol, and it's old, slow, but it does work. I think they talk about RIP2. There it is. RIP2, less traffic. And one thing they don't really mention on here, what RIP does, there's a time, I think it's like 30 seconds, actually sends out a broadcast like every 30 seconds to all routers it knows about and says, hey, here's all the stuff I know about. Then each other router receives that and then sends that out so you can figure out where you need to go based on what you get from other routers. Okay?
It does that in case a router goes down. It can actually figure out the best
right, for the best way. I mean, it's good. It's a good protocol. It's just older. Okay? It says less commonly used. I think it's actually used quite a bit. Okay? All right, BGP, Border Gateway Protocol, uses different types of messages. Doesn't broadcast as much as this one. More complex, or they say the most complex. Here's the one I like. Link state. It says each router independently maps and determines the best way to get there. And instead of telling all the other routers everything that you know, you only tell it the stuff that's changed. So it makes sense. Okay. In OSPF, open shortest path first. Okay. No hop limit. It's complex algorithm, and again, it determines how to get there, but not based on just hops. Okay. There's a whole bunch more in depth in other classes. Intermediate system to intermediate system. Okay. Again, internal only. And you see this internal routers only. Why would I need a router for an internal network? Well, we have two different subnets here at Rose State, and those actually route together. So that could be one reason to have it. And I was actually sent an email to our IT guy Saturday because I was up there Saturday morning. I was transferring 16 gigs from my office to room 221. Okay, 16 gigs of data. I'm the only one at the school on a gigabit network. How long should that take?
60 minutes.
Should take seconds. It took like 12 minutes. What the heck? I was transferring at 10 megabits per second. Internal, that's nothing. It should have been doing a lot faster than that. But we had a power outage, months ago now. And our routers down the hall reset, and they weren't backed up. So the routing tables are screwed up. At one point, to go from here to one part of campus was actually going all the way out to OneNet and back. So obviously there's still an issue with it because 10 megabits for an internal network is nothing. It's not fast enough. Okay, but it works good. Okay, hybrid, you can use a bunch of different ones. You're going to go through all these in the routing class. Okay? Faster convergence time, low network overhead. There's just way beyond me since I've never done the Cisco stuff. Okay, here's all the different protocols. They just list them in a chart, and we're just about done. Gateway. That's what a lot of us nowadays, we have a gateway. Gateway and a router are pretty much the same thing. Okay? That's why our computers have a default gateway, which is normally your router. Okay? Combination of hardware and software. It can be software or it can be hardware. It can be both. Okay? Repackages it. What does that mean? Well, it means it's taking the packet destined for Google. It's got our internal network address on it. It repackages it with its information on it and sends it out to Google. So it repackages it, and that's used all the time. Email gateways, internet gateways, LAN gateways, firewalls, there's just all kinds of those. And you have these, you just don't realize it. You have some of those at your house. Okay? That's the end of this chapter. Yeah, that was short.